In this video, I'm going to go through review 2, everything about coordinate geometry. So for number 1, the endpoints of one side of a regular pentagon are -1, 4 and 2, 3. What is the perimeter of the pentagon? Well, remember, a regular polygon has all sides that are equal and all angles that are equal, and a pentagon is a polygon with 5 sides, so something maybe like this. And if I want to find the perimeter, I need to find the length of all the sides and add them up. But if I'm thinking on my toes, if all 5 sides are equal, then all I really need to do is find the length of one side and then multiply it by 5. And because this is on the coordinate plane, I can use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now I'll label my first point here is x1, y1, and my second is x2, y2, and I'm going to start making some substitutions. x2 is 2 minus a -1 is going to be adding that 1. Remember, minusing a negative is the same thing as adding a positive. Plus y2 minus y1 squared. Now I'm going to type that into my calculator with everything except for the radical. And what that ends up simplifying to is 10 under the radical. And notice that's an answer choice, but that is only the length of one side. If I multiply that by 5, that would give me the length of all the sides added together, or answer choice 2. Line segment NY has endpoints -11, 5 and 5, -7. What is the equation of the perpendicular bisector of NY? Well, for the perpendicular bisector, you need two things. In order for it to be perpendicular, you need to have a negative reciprocal slope. And to be a bisector, it needs to cut it in half. So you need to know what the midpoint is because it's going to go straight through the midpoint. So the first thing I'm going to do is I'm going to plug into the midpoint formula. Remember, that's just the average of the x's, comma the average of the y's. So I'm going to add up my coordinates and divide by 2. So for the x coordinates, that's going to be -11 plus 5 over 2. And for the y coordinates, it's going to be 5 plus -7 is just -7 divided by 2. -11 plus 5 is -6 divided by 2 is -3. And 5 minus 7 is -2 divided by 2 is -1. So that's the midpoint. That's a point that I know is definitely on my line. Now what I'm also going to find is the slope between n and m. If you don't remember the slope formula, remember that's just the change in the y's divided by the change in the x's. So in our case, y2 is -7 minus 5 divided by 5 minus -11 just becomes +11. So when I do that, -7 minus 5 is just -12, and 5 plus 11 is 16. When I reduce this slope, I end up just getting -3 over 4. But remember, you want the slope that is perpendicular to that. So I'm going to flip that and negate it. So here are the important pieces I need. I found the perpendicular slope, and I found the midpoint of that guy ny. So this line that I'm going to have is going to go through that midpoint, and it's going to have that slope. So I'm going to plug into point slope form of a line, which is y minus y1 equals m times x minus x1. And all these formulas that I'm pulling out here, you're going to need to remember for the midterm. So it's called point slope because all you need is a slope and any point on the line to write the equation. So y minus y1, in this case y1 is just that -1 from my midpoint, equals my slope, 4/3, times x minus x1. When I subtract -3, it just becomes +3. So this is the formula of the line that is perpendicular to ny and that goes through the midpoint of ny. So my final answer is just answer choice 1. For number 3, which equations represent the line, that should just say equation, represents the line that passes through the point negative 2, 2, and is parallel, remember that just means it has the same slope, as y equals 1/2 x plus 8. Well, first off, I could rule out 2 and 4 because they don't have a slope of 1/2. Remember, the slope is that number that's being multiplied to x there. And if it needs to go through the point negative 2, 2, you've got two options. You could try substituting in this point into x and y to see if it makes the equation true. Or you could just set up the equation in point slope form. Something like this. So what I'm going to do is I'm going to rearrange this equation so it says y equals. So I'm going to distribute that 1/2 to get 1/2 x. 1/2 times 2 is just 1. And I'm going to add 2 to both sides so that I have isolated y to get 1/2 x plus 3, which I note is the exact same as answer choice 3. Again, if you wanted to substitute this in for x and y to see which one it makes true, that's also a good idea once you've ruled out answer choice 2 and 4. For number 4, which equation of a line? Which is an equation of a line that is perpendicular to the line whose equation is this and passes through negative 6, 1? Well, if y isn't isolated, it doesn't help me too much, so I'm going to start just by dividing out that 2 so that I can see that my slope is 3/2 and my y-intercept is negative 5. So if I need it to be perpendicular to this line, it needs to have a negative reciprocal slope to 3/2, which is just negative 2/3. And it also needs to go through the point negative 6, 1. So I'm just going to plug into point slope form to figure out what this equation should be. So y minus y1 equals my slope times x minus x1. Again, minus a negative 6 is just plus 6. I'm going to distribute that negative 2/3. Negative 2/3 times x is just negative 2/3 x. And if you're not sure what negative 2/3 times 6 is, you could always just plug that straight into your calculator. It's negative 4. So if I add 1 to both sides to isolate y, I'm just left with y equals negative 2/3 x minus 3. So I get answer choice 2. For number 5, in the diagram below, triangle ABC has vertices A, B, and C. What is the slope of the altitude drawn from A to BC? Well, remember that the altitude has to be perpendicular to BC. So if I know the slope of BC, I can just find the negative reciprocal. So here I'm actually just going to count because they gave it to me on a coordinate grid. So I go 1, 2, 2 up, and 1, 2, 3, 4, 5 over. So my slope of BC is just my change in y divided by my change in x, which means my slope perpendicular to BC is just the negative reciprocal, negative 5 over 2. Number 6, the accompanying diagram shows 2 cables of equal length supporting a pole. Both cables are 14 meters long, and they are anchored to points in ground that are 14 meters apart. What is the exact height of the pole? All right, so this to me looks like a Pythagorean theorem problem. I've got a right triangle right here. The hypotenuse is 14. However, if you recognize that this is an isosceles triangle, that altitude is also going to be the median. So both of these pieces are going to be 7. So if I'm plugging into that Pythagorean theorem, a squared plus b squared equals c squared, one of my legs is 7, one of my legs I don't know, and my hypotenuse is 14 squared. So 7 squared is just 49, plus x squared equals 196. I'm going to isolate x squared by subtracting 49 on both sides, and I get x squared equals 147. So I notice all of my answers seem to be simplified a little bit here. So I'm looking at radical 147, and I'm thinking, what could I break it up into so that one thing is a perfect square and one thing isn't? Well, you could try a couple numbers in your calculator, but if you divide 147 by 3, you get 49, which is a perfect square. So I'm going to break up 147 into radical 49 times radical 3. Radical 49 simplifies to 7, radical 3, so my answer choice is 3. Triangle Dan has those coordinates. Using coordinate geometry, prove that Dan is a right triangle. Well, in order to prove that something's a right triangle, I'm going to need to, at some point, assert that it has one right angle. So the way I'm going to do this is by using the slopes and looking for perpendicular lines. So I sketched the picture to see that DA looks like it could be perpendicular to NA, so I'm going to try to show that here using my slope formula. So I'm going to subtract y2 minus y1 over x2 minus x1. I get negative 3/6, which simplifies to negative 1/2. So if this is perpendicular to NA, I'm going to want to get 2 for my slope for NA. So let's see what happens. 1 minus 5 over negative 4 plus 2 is equal to negative 4 over negative 2, which, lo and behold, simplifies to positive 2. And these right here are negative reciprocal slopes. Now that's good news, because that's enough to say that DA is perpendicular to NA, which in itself is enough to say that A is a right angle. Why is that? That's because perpendicular lines form right angles, which is enough to say triangle DAN is a right triangle, because right triangles have one right angle. Number 8, in the coordinate plane, the vertices of triangle PAT, I plotted there, and I want to prove that PAT is an isosceles triangle. Remember, an isosceles triangle is one that has two congruent sides. So this to me sounds like a task, again, for the distance formula. Again, if you don't remember it, you subtract your x's, square them, you subtract your y's, square them, and that's all under a radical. Now, visually looking at this, it looks like PA and AT are going to be my congruent sides. So I'm going to set up a distance formula to find the distance between A and P first. Now, I'm going to write down my coordinates again, just in terms of organization, to be able to label one of them as x1, y1, and x2, y2 when I substitute into the formula. So that's going to look something like x2 minus a negative 4, again, it's going to become plus 4, and then y2 minus y1 squared. When I type that into my calculator, I'm going to type in everything except for the radical, and I find that the distance between A and P is radical 130. Now I'm going to do the same thing for AT, and if this really is an isosceles triangle, I should get the exact same distance. Now really you could do distance formula 3 times if you want to find the length of PT, but I know it doesn't look to be congruent, so I'm not even going to bother with it. x2 minus that x1, again minus a negative 4 is plus, and y2 minus y1. And I plug that into my calculator, and lo and behold, it is in fact radical 130 again. So what does this show? This shows that AP is equal to AT, which shows that triangle PAT is an isosceles triangle because it's got one pair of congruent sides. And that's all you need to prove something's an isosceles triangle. Now, for part B, it says state the coordinates of R such that quadrilateral PART is a parallelogram. Now, when I plot R, there's 2 points that make this a parallelogram. It's going to be something over here I could plot, and something over here I could plot. But if I want this to be part in that order, it's got to be this point up here such that when I trace it around, it spells part in either a clockwise or a counterclockwise motion. The question is how to get that point. And it starts with understanding properties of parallelograms. Remember that parallelograms have opposite sides that are parallel and the same distance across. So I'm going to count the slope from P to T. The slope of PT is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So the slope of PT is 4 over 6, or 2/3. And I'm going to apply that same slope from A, because I know opposite sides should be parallel and the same length. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Looks like that's a pretty good point for R. And just to make sure, I am going to connect A to R and R to T. Now visually, if I got rid of this diagonal right here, this would look like a pretty good parallelogram. Let me just write down the coordinates of R, because it asked to state the coordinates. That's 2, 9 if you count carefully. But I still need to justify that it is in fact a parallelogram. So to prove it's a parallelogram, the easiest thing to do would be using slopes to show that opposite sides are parallel. Well, with the work that I have here, I've already shown that the slope of segment AR and the slope of segment PT is that 4 over 6, or 2/3 if you reduce it. And if you count carefully on your graph, you'll find that the slope of PA and the slope of RT, to get from A to P, I'd have to count down 11, then go right 3. Same deal for R to T. I'd have to go down 11, then right 3. And remember that parallel lines have the same slope. So what this information shows is that both pairs of opposite sides are parallel. Therefore, quadrilateral part is a parallelogram. Now there's lots of ways to do this. You could show that opposite sides are congruent using the distance formula. Really, we have one distance already, you'd have to do a few more here. Or you could show that one pair of sides is both congruent and parallel, but to me slopes is the fastest way to go about that.